Welcome to another video for Ivy Tech Community College. In this video we're going to be looking at modeling another sheet metal part, which you can see here. And again, you can download this PDF from Blackboard if you need a copy of it. It should be in the week by week folder for our class. And watch out for this one because it's a metric file. So we're going to use the sheet metal template, but you have to use a metric file. So jumping over to Inventor, I'm going to go to New, switch to my metric folder, and I'm going to go sheet metal din.ipt. Or actually, let's use just regular millimeters. We're going to go sheet metal millimeter.ipt and hit create. And one measurement that is missing on this handout I gave you is the height of this flange right here in the middle. They don't give you any height information for that on this drawing. So we're going to assume outside to outside here that that is a size of 20 millimeters. So I notice that that is missing on the drawing, so we will use that as necessary. Alright, so the first thing that I'm going to do is I'm going to start by working on this area up here and just kind of sketch that out and add the holes in there, and I'll show you a couple other tools that we didn't look at last time. So I'm going to start a 2D sketch on the XZ plane and project in my axes. And then I'm going to start by drawing a rectangle, and this rectangle is going to be .36 wide, and I'm going to go 50 tall. And remember, we're using millimeters here. And then I'm going to use some symmetric constraints to center everything up. And I'm going to go ahead and hit Finish Sketch and check my sheet metal defaults, and this is actually a half millimeter thick, so that's good to go already. But I'm going to change the type down here to carbon steel. So we have the material as carbon steel. And I'm going to use the face tool now to take that sketch that I made and turn it into an actual 3D object. So now I've taken that sketch and I have some actual 3D sheet metal that I've created, and I'm going to start adding some other features to it. So you'll notice that we have a couple of rounds on this, so the outside corners are actually rounded off with a radius of 6. So I'm going to do a corner round on this, which is similar to a fillet of 6 millimeters. And I'm just going to pick these corners, and you'll see when I do that it automatically rounds those off. And hit OK. And I'm going to add in a couple of holes here at the end, but before I do that, I'm going to go ahead and put this tab in here as well. And there's a couple ways you could do that. You could do it as a sketch and use the face command, but a little bit faster way, in my opinion, is to use the flange tool. So I'm going to pick this edge for my flange, and I'm going to drop out the extra options here and go to width. And my angle in this case is going to be 0 because I want it to be flat. I just want to extend it out. The width of this flange is going to be 16 millimeters from our drawing, and I want to offset that. And I'm going to click on the orange arrow here, and I'm going to offset it from this face. And looking at the print, that distance should be 10 millimeters. And then our depth, or the distance that this protrudes out, should be 12 millimeters. And it doesn't look quite right, but once we round off the corners of it, it's going to look right. So it looks kind of funny right now. So I'll hit apply and then cancel. I'm going to go right back to my corner round and pick up these two edges and hit OK. And now we're ready to put some holes on this part. So to do this a little bit easier and faster, I'm just going to make a sketch on top of the whole thing. And I'm going to project this entire face into my sketch. So I'm just going to project the whole thing in. And watch out, because these holes are not concentric with these fillets. So if you look, this fillet has a radius of 6, but this hole is 8 millimeters away. So a lot of people mess this part up and they make this circle concentric with this arc, and it's not if you look at the measurements. So don't let that trick you. So I don't want to click right here. I'm actually going to come a little bit down here, and my diameter should be 6, and it should be 8 millimeters away from either edge. And then I'm going to make one more circle over here, same size of 6, same dimension away from the edge of 8, and then the center to center distance on these is 16. And we just need our circle down here as well, size of 6, and the dimension there is 6 to the center, and it should be centered up this way as well, which would make that 8. And at that point we're ready to cut these out. So I'm going to go to Finish, go up here to my Cut tool, pick all of the holes, go up here and cut through all, hit OK, and there we've got the holes cut out. So we're ready to make the next flange now that drops down. So I'm going to go up to my flange tool, and this is going to be a full width flange. So I'm going to pick the top edge, and my angle is going to be 90. So I'll flip that the other direction using this button, and this is the dimension that we're missing. So we need to know the height from here to here when we put that flange in, because we're actually wrapping that down now, and we're going to assume that it's 20 from outside to outside because they haven't given us that dimension. So I'm just going to say my height here is going to be 20, and this will give me that outside to outside measurement. So I'll hit OK. Then I'm going to go right back in and flange it again so that I can get the piece that comes off this way, which would be right here. So the depth of that is actually going to be determined by this 61. So I'm going to go ahead and grab my flange tool, click the edge, and the angle is going to be 90. I'm going to measure outside to outside, and we know that we have 61 all the way across, and we have 36 to this first flange, and it's measuring to the outside right here. So what I really need to know is what do I have left over from here to here. So if I do 61 minus 36, I've got 25 from this edge over to the end, or 25 and a half if you go outside to the end, because we have 0.5 millimeter thick sheet metal. So I'm going to go 25 and pick my other option on the inside here, hit OK, and then I like to check and measure one more time, so I'm just going to grab the measure tool and measure from here all the way back to the other end and make sure that that's 61, which it is. So watch out for the thickness of the sheet metal when you make these parts, because they could throw you off by 0.5 millimeter or so. So finally I need to add in the other flange that goes up here, and then all the holes. So I'm going to use the flange tool again and click on this edge, and I want an angle of 0. And this is not a full width flange, so I'm going to expand out my options and go to width. And the width of this particular flange is 12 millimeters. And offsetting it from this face, I want an offset of 0, so it's flush with the end. And my distance, or my height, for that flange is going to be 62 minus 50, so I've got 12. And I'll hit apply, and then cancel, and I can put the corner round that goes in between here. So I'll grab the corner round tool, pick that inside edge, and hit OK, and then finally I just need to put the final holes in here. So I'm going to go and make a sketch on here. Since I have several holes, it's going to be faster if I just sketch them out instead of using the hole tool over and over. Or another way that I could do it is if I make a hole and pattern it, so perhaps we should look at that way instead. So I'm going to grab the hole tool. There should be a diameter of 6, so I'm going to click right here, grab my first reference off of this edge, which I can see that distance should be 6. My second reference off of this edge should also be 6. I'll hit apply and cancel, and now I can do a rectangular pattern. So I'm going to choose this feature, and my direction, I'm going to use this edge as my direction. Flip the arrow. I need a total of 5 holes, and they should be 10 millimeters apart. So I can hit OK. And there is my finished sheet metal model. So there's several different ways you can attack this thing, but that's the way that I would do it normally. And you know, you could sketch more or less as you do this. depending on what you like to do. So I'm going to save this to my desktop as Lab H and close it out, and I'm ready to make the drawing. But first, remember, you have to hit the Create Flat Pattern button, otherwise you're not going to be able to make your flat pattern drawing. So I'm going to generate that flat pattern. You can see where it has calculated the bend allowances and the bend locations. I'll go back to my folded part and save one more time. Close this out, and I'm going to create a new drawing file using the Ivy Tech template. So I'm going to call this Lab H folded. This is in millimeters, and I'm going to say that we could probably try this at a 1:1 scale and see what happens. Alright, so remember that your first page is always going to be your folded model. Your second page is going to be your flat pattern. So I'm going to make a base view starting out and choose my file, which would be Lab H. So I'm going to choose my part file for this sheet metal object. I'm going to stay on folded model, and I'm going to use the same front, right, and top views that they have on here. So even though this is technically a top view in my Inventor, I'm just going to use this as the front view because it's the most descriptive and it shows the longest dimension. So I'm going to do a front view, right, top, ISO, and then I can kind of drag these around so that they fit a little bit nicer. And I like to set my ISO view to be shaded always. And you could maybe even get away with scaling this up. You could try it at a 2:1 possibly, or a 1.5:1 maybe, because that's probably going to be too big. So if you wanted to, probably the best choice on this would be to go 1.5:1. That could probably be made to work. It's a little bit cramped, so it's up to you if you want to really kind of cram everything in there at 1.5:1, or you could stay 1:1. So I'll probably just stay 1:1 in this case, but it's going to give me a lot more room for dimensions. So then I could add my center marks to center lines with the center mark tools on the Annotate tab. So remember to center mark all of the holes and put center lines in for the side views of them. And I'm going to go ahead and make a new sheet. And I'm going to call this Lab H Flat Pattern. And this one I probably can get away with a 2:1 since I'm not going to show an isometric view. So we'll see what happens here. So I'm going to place a new base view of Lab H. And this time I'm going to choose Flat Pattern. And let's try a 2:1 scale and see if that will fit. That's just going to be too big, so I'm just going to stay 1:1, keep things easy. That's going to give me a lot of room for dimensions though, which is good. And remember, on the flat pattern sheet, it's kind of pointless to show an isometric view because it's pretty much the same as your front view. So now I'm going to put my center marks in here. And at this point you can start placing dimensions. And remember, you need to put overall dimensions on here, and you also need to dimension to the fold lines. So you're going to fully dimension this part. Every shape, every location dimension, every size dimension, dimension the thickness of the sheet metal. So if you have correctly done this drawing, that should be totally full of dimensions when you get done. If you have 2 or 3 dimensions on here, you have not done everything you need to. So a couple things I need to fix here. I need to change my scale back to 1:1. So make sure you pay attention to these details. They can make or break your drawing. Another thing is that this is actually dimensioning in inches right now. So I need to switch that. So I'm going to go to Manage. Actually, Tools. I'm going to go to Tools, Document Settings, and I'm going to change this to ANSI millimeter. And you'll notice when you do that, that this dimension will not update, so I'm going to go ahead and just delete it. But if I replace that same dimension, now that I've switched over to metric, it'll come in at the right size now. So make sure you go up here to Tools, Document Settings, and change over to Metric for your dimensions. So you can dimension your whole drawing now at this point. Most of your dimensions are going to be in the flat pattern, and make sure you dimension to these fold lines, as well as the overall dimension, so they know what size of metal to start with. And then on your page 1, your folded model, mostly what you're going to give here are the lengths of the flanges. So dimensions that you would probably want would be things like this, from outside to outside, so they know the size of that flange. You can also give angle dimensions if you need to, so they know that that's a 90. So mostly you're going to be giving on your folded model flange lengths and angles, so they know how far to bend them and how long the flanges should be. But all the hole sizes and fillet sizes and overall sizes for the part are all going to be determined by this flat pattern sheet. So this is really honestly the most important sheet. The folded model just shows them what it should look like when they get done, kind of as a final check. They can look at this and say, okay, well that's what the bracket looks like, so we've got it. So that's some tips for Lab H. I'll let you do all the dimensioning and annotating, as that takes a while, but I think you should be able to handle most of that because it's repetitive. So give that a try on your own now. Good luck, and I'll see you in class.